So let's look at this section 6.2. What we're getting into now is actually evaluating and working with these exponential equations. So this first part is similar to what we would do when you want to know what would the value be after 3 days or something. So we want to find our function f of 3 for our value below. So I'm going to replace my x with a 3, and I do it over here as well. Now, your calculators on your phones have this like caret button normally that raises it to whatever power you want. So you could type in 4 caret to the third is one way to do this in a calculator. You could also do 4 times 4 times 4 in a calculator, and that would also work. So whichever way. If you have questions about your particular calculator, how to do this, we can look at it. You can also, Google has a calculator that you can use, so that might be helpful for you as well. You could type it in there. So if you have calculator issues, please let me know. So for the next one, again, it's telling me put in 2 for x. So f of 2 is equal to 1/8 times 5 to the 2. So again, you should even possibly have a squared button, or you could do 5 caret 2, or if you just know what 5 times 5 is. So 1/8 times 25, and then if you wanted to simplify this, 25 times 1/8, or 25 divided by 8, give me 3.125. This one's a little trickier. So this might be one where you really need to figure out how your particular calculator works to be able to do the negative power. So what I have here is 9 times 1/5 to the -2. We did talk about negatives. Remember, that just flips it. So if you remember your exponent rules, you could change this into 9 times 5 to the 2. But if you don't want to remember those negative rules, you can enter this into the calculator. And you could just do 1/5 caret -2. And that would work. Again, if you don't know how to do the caret, please let me know. And we can work on that for your particular calculator. You would also be able to Google if you need to. Probably if you typed 1 divided by 5 caret -2, it might even read that within Google and know what you're talking about. But when I do that, I get 25. So I would do my 9 times that 25, which what's 25 times 9? I get 225. And our last one, we have it to the 7th. So I have 1/2 times 2 to the 7th. Again, you can do the 2 caret 7. You could also do 2 times 2 times 2 times 2 times 2 times 2 in your calculator. It will also work. So 2 to the 7th gives me 128. So 1/2 times 128, I'm going to divide by 2. So this can be very calculator heavy. If you have issues with a calculator, let me know. Our next one is a find x if the function is 64. So that's telling me that 4 to the x equals 64. The best way that I can tell you to do this one is to try to break down 64 into 4s. So if I did 64 divided by 4, I get 16. If I do 16 divided by 4, that would be 2 4s. So I could rewrite 64 as 4 to the third. And now when I'm comparing, well, the 4s match. That means that x must equal 3. So that's the easiest way to break it down. If this was multiple choice on Apex, I would recommend just plugging in the different options and seeing what you get. Okay. Our next ones are dealing with this idea of any type of exponential function can be written this way. f of x equals a times b to the x. A will be your start, and b will be your rate. Okay? So if I have a town population that can be modeled by the function f of x equals 17,200 times 1.1 to the x, identify your initial value. I guess I could also write this as initial value, if that's the wording that they're going to use. Value. Start, initial value, something along those lines. So my initial value is whatever's in the A place. Well, that's at 1720. So initial value equals 17,200. The next question is the population increasing or decreasing? So in a rate of change problem, or in an exponential growth problem, you increase if you are greater than 1. Okay? And you decrease if you are less than 1. So looking at this, I have 1.1. 1.1 is definitely bigger than 1, which means this is an increasing situation. My population is growing. The growth factor or growth decay. So this is another way I would say the growth rate. So the growth factor or growth decay is whatever's in the B position. So my growth is equal to 1.1. And how does my population change each year? It increases at a rate of 1.1 each year. Something along those lines. And then this is our next town. It's a very similar type of problem. We're given the 19,820 times 0.98 initial value. Initial value is whatever's in that A position. It's whatever's out in front. So initial value, 19,820. Increasing or decreasing? Well, I come over to my rate. 0.98 is definitely less than 1. So I would say this is decreasing. Is this growth or decay? Well, if we're, what is the growth rate or decay rate? Again, to find our growth rate, our growth decay rate, that's our B position. So what is being multiplied on here? That's that 0.9. So we would call this a decay problem because we're decreasing, and it's 0.98. That's our rate. So this population is decreasing by a rate of 0.98. Okay. Next is writing the equations. It says use the general formula for exponential functions. F of x equals a times b to the x to write a specific function with the initial value of 61 and a growth factor of 3.5. So when we're writing this, be sure to put out your f of x first. Equal to, the A position is that initial value. We're told initial value is 61. Got it. Put in our time symbol. Got it. Our growth, our rate, whatever, our growth factor, that's whatever's in the B position. So it's what comes next. So I put in the 3.5 next. And I raise it, always, always, always raise it to the x power. Okay. Very similar situation. We want to write the function. Always start with f of x. Find our initial value first. That's the 3. So that goes in our A position. Our rate, Well, this is written as a fraction. You can leave it as a fraction. There's no issue if you want to leave it as 2.3. Sometimes with fractions, they like to put in parentheses just to make it look prettier. But you don't even have to change it to a decimal. And always, always, always to that x power. And our last one, this one deals with a special formula for interest rate, where you have annual time, so a compounded time will equal the principal 1 plus interest to the t. Okay? So what does all this mean? This is just the formula for interest. There may be a quiz question about interest. Use this formula. So how much would 400 invested? So P is our initial value kind of in this case, or our investment, which is the 400. Interest, that's I, is our interest rate, which is 5%. 5% should be rewritten as 0.05, so we can use it as a decimal. And then T is time. We want to calculate this for 6 years in this problem. So we're going to plug all of that in. AT will equal whatever 400 times 1 plus 0.5 to the 6th is. Okay? We're going to calculate this out, so we get 400 times 1.5 to the 6th. That's where you're going to use your calculator. And I get 1.5 to the 6th, which would be 400 times 11. Times 4.4 times 400, which will give me 45,000. Oh, 602.5. So that would be our final answer here. If you have any questions, let me know.